Hi guys, welcome to part 1 of the calculus tutorial. This is for 2.7 calculus and I'm going to be going over through the 2023 mock exam. So not the NCEA one, but it's just a mock version. And to those of you who did English this morning, I hope you did well. So, question 1. A function f is given by f of x equals 3x squared minus 2x plus pi. Using calculus, find the gradient of the graph at the point where x equals 1. Alright, this question is like extremely easy. It's usually the first question of every exam, this sort of find the gradient where you're given an x coordinate. So all you have to do is two things. Derive and then just plug in given x value. So if we derive it, you can write it as dy over dx, or I just write it as f dash of x because it's easier for me. 3x squared, take power here and we multiply it by the 3, or just 6x because we take 1 off the power, minus 2x. If there's just an x, that x just goes away. And then pi, because there's no x, it just completely goes away. So this is the derived equation. Now we're just going to plug in the x value. So when x is equal to 1, equals 6, 1 minus 2. So that will just be, when f is 1, 6 times 1 minus 2 equals 4. So that's your final answer. And that would just be worth a simple achieved mark. Next question. The graph of the function f of x of the local minimum. Okay. It's really important we don't get confused between maximum and minimums. So what I like to do with these questions is sort of visualize what's going on. So we know that this is a positive cubic. So if I just sort of draw out a little mini sketch, it doesn't have to be accurate, but we know it will look something like this, right? It will end positive. Now this is the minimum, and this will be a specific coordinate we don't know yet. And then there's also going to be the maximum, which we're not really worried about in this question. So we're just going to ignore this, okay? So determine the coordinates of the local minimum. So what you always have to do is just derive the equation first, because that's what you do for most things, just derive. So f dash of x will equal... Okay, when we're deriving fractions, we just take the power and multiply by the top number. So that will be 3 over 3. X squared, take 1 off the power, remember, negative 2, so negative 4x. That's just going to become plus 3 because there's just 1x, and that's our, now this also simplifies to 1, so we can just write it as x squared because we don't write 1s because it doesn't make any sense. Now this is a quadratic equation, so we can make it equal to 0. To find out what our x values are. X squared minus 4x plus 3 equals 0. If you put that into your graphics calculator, or if you factorize it, you should get x equals 3, or x equals 1. Now we know the minimum x coordinate has to be greater than the x coordinate for the maximum, so we know that this is our coordinate for the minimum, so we can ignore this. So if we just plug in, to get the y value, all we need to do is plug it in the original equation, not the one we derived. So we can just write y equals 1/3 3 cubed minus 2 3 squared plus 3, and then plus 1. Okay. Once you do that, y should equal 1. So the coordinates are equal 3 and 1, because that's your x and your y. Okay. Pretty straightforward question. This is a merit question. If you find the coordinates of the local minimum, you'll get a merit. So, merit for that. If you correctly derive it, and you have to make sure you set it to 0, so have to set it to 0, so this bit would get you an achieved. Okay, next question. The diagram shows below the graph of the function y equals f of x. Sketch the graph of the gradient function f dash of x. Alright, so these questions are actually really easy and they're pretty straightforward. You can see we started off as a cubic, okay, which means it will be something like this. When we derive something, remember we take 1 off the power, so that will become a parabola x squared. So that means this has to be a parabola. Now we got to make sure we line up. We have to look for the turning points because that's where our x-intercepts have to be. Okay, the turning points is where we have to make our x-intercepts. So we've got one here and one here. That's roughly at 3 and -2. So if I sort of look on my graph here, we've got one at -2 and one at 3, and then we just got to make sure our and notice how this is a negative cubic because it ends going down, so that means we're going to have a negative parabola. Okay, so that means we're just going to have some, will just sort of look something like this. Okay, just make sure that the turning point here is more than 0. So you're not having your turning point at 0. Okay, oh, like this. Okay, so this is just if you have a negative parabola with the correct x-intercept, so these line up and this is above 0, you would get an achieved.